All right, we are live and welcome to episode 6 of High Vibe TV. And if you like this channel, please subscribe and hit the like button. And another way you can also support is to support by buying some of the affiliate links down below, including the amazing masterpiece, which is a zeolite that is scientifically proven to remove such toxins as graphene oxide, glyphosate, microplastics, and more. Well, if you're like me, you've been hearing for years about water shortages and gloom and doom for such desert towns as Las Vegas and Phoenix, and how water scarcity is the way of the future. And what if I were to tell you that none of that is true? That in reality, there is a vast ocean of clean, usable, potable water that lurks beneath us. I mean, after all, where does all the water in the ocean and the geysers and streams emerging from mountains come from? Well, that is the topic we're going to discuss today. And with me, I have Mr. Tyler Woodard. And he is somebody who has been in the business of actually surveying and drilling for primary water. For how long have you been doing that, Tyler?
Oh, just a couple years,
So you're pretty
not too
new,
long.
but
Yeah,
sounds like you can learn a lot in 2 years by doing that.
you
Like,
can learn a lot in a day, and you can
yeah, I
learn
was
even
gonna
more in a couple
say,
weeks. And
uh,
if you keep your eyes and ears open, I mean, it's not rocket science, but it is earth science, and we're standing on the shoulders of giants who dedicated their life and a tremendous amount of research to putting forth these hypotheses and bringing together information to support this idea that just seems like common sense observation.
so I first learned about this topic through our local activist, Deborah Tavares, who's always broadcasting the all kinds of interesting things that are going on in the world. And one of her passions has been primary water. And she did many discussions with a man named Pal Power, a Hungarian refugee who came here in the 50s, who started drilling for primary water as early as the 1961, I believe. How did you personally come across this topic, and what in the world made you decide to jump into it into the level that you have?
Well, indirectly in the same way, through the same lineage. So Paul Power, who Deborah DeForest discovered and featured in a few Herd podcasts, and big hat tip to her. She turned on a lot of people to primary water, and we've seen other people in the Instagram, TikTok sphere covering primary water that I've talked to, and they got turned on by Deborah Tavares. Folks like Cultivate Elevate, thanks to Deborah's work there with Paul. So Paul Power learned about primary water while he was in school in Ojai, California, from Dr. Stefan Ries, another European refugee who came over from Germany in the 30s. And he's kind of our godfather of primary water. There was another fella before him, before his lifetime in Scandinavia, a Finnish professor of geology who received a Nobel Prize nomination for his paper drilling for primary water in granite rocks. And he was drilling granite promontories, peninsulas, and islands off the coast of Sweden and finding pure, potable, spring quality water in the granite fractures off the coast in the ocean. He died before the Nobel Prize came about, so he was put out of the runnings. Um, and then separately, Stefan Ries, though he was probably exposed to that, put forth a theory of primary water, and Paul Power was his student. My mentor, Mark Burr, learned from Paul Power about 10 years ago, and Paul passed away about 2 years ago. So Dr. Reese was first generation, Paul Power was second generation, Mark Burr, Primary Water Technologies, was third generation, and a physicist friend introduced me to Mark, and we were mutual friends, and said, "Hey, I think you'd be into this based on what I was working on." After the Maui fires, I was over there doing relief work and saw that the water went bad after the fire. There was volatile organic compounds in the municipal water supply of both West Maui and upcountry Maui. And I started turning my eyes to the water issue. And that directly, indirectly led me back to the desert and finding primary water technologies and this lineage of primary water and magmatic, volcanic, earth generated, mantle generated, rock generated water. And it was like, well, that's a good solution. That sounds even better than atmospheric water generation and desalination, reverse osmosis technology. If we have oceans of fresh water under the oceans, if we have Great Lakes beneath the mountains, and it comes close to the surface, and we can just find those veins of water and tap it, then that seems like the most simple, easy, quick, economical, viable, all-around best solution. And that is also not a new idea. That idea has been put forth for 50 plus years. Stephen Reese testified before Congress in 1960 to this effect, saying, hey, we don't need to do these dams and levees and reservoirs and aqueducts. There's a river in every fault, and we can tap these locally where it's needed and have shorter water lines to where we want the water to go, whether that's farms or cities. So this is a ministry gospel of science and water that's been going on for 60 years.
Wow. So when you say the word theory after primary water, it makes me wonder, and it's going to make everybody else wonder as well. Uh, has this indeed been proven beyond reasonable doubt? And when you're drilling for primary water, how in the world do you really know if it's primary water or just an untapped reserve of uh, water that results from atmospheric precipitation? Um, it seems like, is there some kind of testing you do that can distinguish the differences in chemical structure, or exactly how does that work?
Okay, so before we get into the ascertaining, how about the theory? I like to use the word theory because I think science speaks far too often in terms of absolutes. Go look at a grade school, high school, college textbook, and oftentimes they speak in absolutes and they employ all sorts of logical fallacies, and they can be dismissive of alternative theories, which may in fact be correct, like physics books addressing the ether, or US history books addressing various political things in the past. And they said, oh, that was just, it was just a thing, and now we know better. And looking at geology textbooks, they do much the same thing. You go and read the hydrology section of a geology textbook, and the authors can be overconfident and kind of hubris and arrogant and dismissive, instead of giving weighted measure in a proper, empirical scientific view of things. I think it's important that we consider truth in a dispassionate, factual based manner if we're ever going to get to the bottom of things. People's minds can be lazy, and when they read a thing that quickly dismisses something as BS, most people will just kind of dismiss the thing too, instead of look at it. But when we have a body of evidence in front of us that says otherwise, really we should, perhaps it would be best for us to take a look at that, especially when it has to do with such a important resource like water, food, energy, and peace in the world. So evidence. Firstly, there's water where there shouldn't be. desert oases, very arid regions with rivers that support civilization for many, many years that come from springs in a desert. Perhaps like the Euphrates and Damascus and Syria and the Middle East. Those rivers come out of springs. Their headwaters emanate from rocks in a dry desert that hardly gets any rain at all. There are springs emanating millions of gallons a day in deserts in Eastern Oregon to the Middle East and around the world. It's easy to say, this must be snowmelt if it's a place that has water and snow, but in a place that receives practically zero precipitation and has these abundant springs flowing forth, that is an eye-opener. And then to give a quick answer for there, I'd refer you to the Bible of Primary Water, Dr. Michael Salzman's work, New Water for a Thirsty World, available for free download PDF on the primarywaterinstitute.org or the Primary Water Technologies resources page. And this was a book published in 1960. Dr. Michael Salzman was a Southern California professor who followed Dr. Stephen Rees around the West, locating primary water and documenting everything, and published a book in 1960 with a tremendous amount of evidence, footnotes, references, really good academic work. At the same time, there was a $1 billion, $2 billion, $1.5 billion bond before California for a project of dams, levees, and aqueducts. And story goes that the contractors, builders of these concrete projects were so excited with Michael's book that they went out and bought all the copies they could and burned it. So there was an active censorship suppression by the guys who had a lot of steel and concrete to pour and $1.5 billion to make in 1960, which in today's dollars, what would that be? $10 billion. There was some money to be made, a lot of money. There was some money to be made. And this is a common theme of where there's special interests in with profit on the line, that the right thing doesn't always get done for the greater good, for the common trust of the people, for the betterhood of the nation or the world, etc. So New Water for a Thirsty World, fantastic book. Other evidence we've accumulated, we have on our resources page, and we have the work of Stephen Rees locating 700 wells approximately in his career, Paul Power locating about 700 wells in his career. Primary Water Technologies has done about 1,000 projects on 6 different continents and 35 countries and 35 states. So finding water where there shouldn't be water, and finding water that is precipitation independent, that is drought proof, that doesn't run dry in a dry season, as opposed to a shallow well being fed by seasonal rainwater. That's some proof too. Further proof is spring water that is producing at the top of a mountain where gravity could just not be supplying it. The standard spring model is that you have precipitation, rain, snow, percolates through the rock and gets caught between a layer of aquatards, which means to retard the flow of water, to stop it. It blocks it, and you essentially have a straw. And the water flows through the straw, and the straw comes up to the surface, and you have this side up here and this side down here, and the water flows up out. That's the cartoon in all the geology books. But there's many examples where it just couldn't happen that way. I've found springs at the tops of mountain ridges just off the peak, multiple ones flowing out abundantly. It was the dry season. There was no snow melt happening at that point. And people have monitored these springs and monitored them during 3-year, 5-year, 10-year super droughts. And the water output production doesn't is not affected by the big droughts, showing that it's independent. The flow is independent. So
Wow.
that takes that snow, rain, precipitation, aquitard spring model, and it really casts it into big doubt, or scuttles it completely if you want to be, practical and honest. Say,
Sounds
well,
pretty
that model
convincing to me.
doesn't work.
Uh,
Yeah.
as somebody who majored in biology in college, I have to agree with you that if you ask questions, if you step out of line and you question, how did they come up with this idea and make it sanctioned as the only idea that can possibly exist? And you just get a lot of blank stares or pure scorn. And it became apparent to me after several years of going through the process that I think we live in an indoctrination system more than an actual scientific method type of process that in our society, which brings us to the very special interests that you just spoke of. So,
Yeah, when you know it, people look out for themselves and are concerned about how they're going to keep a roof over their head, protect their brand, image, legacy, children, estate, etc. And who was it that said science marches forward one funeral or yeah, one funeral at a time?
I
Um,
don't know who said that,
one
but that's pretty profound.
Science marches forward one funeral at a time. That could be loosely paraphrased from what someone said in the early 1900s, approximately. And that's just to say, okay, let's say here I am, scientist, Bob, and I'm 40, 50, 60 years old, and I've done my thesis and I've written my textbooks, and my theory is important. And then you're, scientist Joe, and you're 20 years old, 25 years old, coming out of school, and you have a theory that makes my theory obsolete. Well, on the one hand, in scientific honesty, we should have open debate and let the merit of the evidence and hypothesis work itself out. But maybe I don't want to become obsolete. I like my position of established, authority as an expert in the field. And if your theory makes my theory incorrect and obsolete, then I'm pushed out into the, out to pasture. And so people are going to resist that, right? People are firstly looking out for themselves, and then, their reproduction and their own interests and whatnot. So, it's an understandable thing.
And we all know
And
how it turned out for Copernicus and Galileo and all of the
yeah.
great thinkers of the
So
past.
it's so important that we come back to empiricism, and we do have the scientific model of, examining and testing hypothesis and following through a process. And people can misinterpret that model or skip the initial steps. Step one of the scientific process is observation, not hypothesis, but observation. First, we observe, then we form a hypothesis, and then we test the hypothesis, and we figure out if we were right or wrong. And you can have a positive or negative hypothesis, doesn't really matter. Test it, against your independent variable and figure that out. So with primary water, that started with Stephen Rees noticing that he was at this castle monastery place as a young man, and they had a well there. And this castle monastery was up on a hill next to a canyon that was quite deep, with a river running through the canyon. So here's the water running down here at the bottom of the river, go up several hundred feet. Here's the building. They have a well. It's relatively shallow, and the water level's up here. How's the water level up here if the water level's down here? How do we have springs flowing out of the top of the mountains where like precipitation couldn't be feeding them? How do we have millions of gallons of water spilling out an hour or a minute in these desert springs where there is no water? Something's up. Where's this coming from? And
So,
their theories have been tested or furthered by geophysicists in the recent 20 years of simulating high pressure, high temperatures with minerals. How could the earth be making water?
so what is the differences in where you're looking for primary water? is it equally obtainable everywhere? Is it only obtainable in certain places where the Earth's fissure is close enough to the surface? Or is it pretty much obtainable anywhere if you drill deep enough? And what is it estimated that the shallowest point is where you can obtain it? I guess that would probably be an oasis or something where it's at the surface. But uh, is it just
Totally. Yeah.
like all over the map as far as how is it just a matter of economic feasibility of how far you want to drill? Is that what the limitations are, or are there some regions where it's utterly impossible to access it?
Okay, that was a lot of questions. So if I don't answer some of them, hit me again, and we'll go. So you already answered the one of the latter questions. How close to the surface can it come? Well, water's being made in the earth, in the basement geologic layers, in the mantle, and that is pushing out and up. It's exerting pressure on the crust. It's probably lifting mountains in topography, and it's flowing through the path of least resistance for pressure equalization and finding the cracks in the rocks and finding its way up. If you drill deep enough, you'll hit this water. It's well known in mining when you're mining deep into the earth and mine shafting down thousands of feet that most mines flood out before they pay out. Meaning you're drilling down and they hit a vein of water and the vein of water floods the mine and they're unable to pump that water out of the mine and they never got to whatever they were going after, gold, silver, whatever mineral they were looking for. This water, when it reaches the surface and breaks through the surface, we call that a spring or an oasis. And you could have a spring that is surface precipitation fed, that's coming off the surface and finding its aquitard channel and pushing up. But a true spring is primary water coming up and breaking through the surface. So between incredible depths, you're going to eventually hit this water, and the surface is where you'll find it. And you can find this water independent of generally geography and geology. That said, it's also like real estate, location, location, location. It finds its way through faults, fractures, and fissures, fractured rock hydrogeology. It's pushing up and it's going to find the cracks and it's going to flood those areas that it can flow. So if you have some solid rock here and you have a little channel here, the water is moving through that channel. It's in the channel. It's not in the solid rock. So it's not everywhere. It's in the water channels, which are in the geologic contact layers between two geologic meetings. And there's a little space that it can push through, or a fracture in the rock. Fracture, fissure, those are all just cracks, terms for cracks in the rocks where the water can flow. It's like you crack your vase or your pot and the water leaks out of the cracks. That's happening, put it under pressure, and it's pushing up. So that brings up another point. Water does two things. It flows downhill, just like shit runs downhill, and it also pushes up under pressure. And that's the part that's not really recognized in your standard geology, hydrogeology books. They look for the way the water flows with gravity, but there's hydrologic pressure from steam pressure pushing and this water creation, and it needs to go somewhere, and water doesn't compress, so it has to find a way to squeeze out, and it's leaking out through the cracks. There's literally water leaking out of the surface of the earth all over, and it's full of all these cracks. Like our bones make our blood, and the blood comes out and circulates around our body. The bones of the earth make the water, and it comes up and circulates through the earth's body and leaks out of the surface and supports life here.
So I'm sure
Which
one of
is
the
just a fantastic idea.
I'm
Yes.
sure one of the most common questions people would have is, how do you know you're not really just, getting atmospheric aquifer water instead of primary water? I would imagine in a lot of cases they sit side by side or in conjunct with each other. Do you actually chemically test, or is there some way of detecting the difference between water sources when you're doing these tests for actual primary water?
Yes, there's practical things you can do to determine that. And that comes down to a matter of how much money do you want to spend on laboratory analysis, because some of that stuff is a bit sophisticated and can get rather expensive. So, um, oxygen in the atmosphere oxidizes things. And we see oxidized minerals like iron oxide rust will be present in surface water that can go down beneath the surface and mix. There's beneath the surface a transition zone based on how porous the geology is between the oxidized and unoxidized layer. And as you're drilling a well, you can take water samples and perform chemical analysis on these water samples and note at what depth did you see a transition from presence of oxidized molecules to an absence of them and a presence of unoxidized molecules. You can also do more complicated analytical chemistry, such as tritium analysis, which is a radioisotope analysis for heavy hydrogen. And tritium is present from two sources. The aurora borealis, high voltage happening at the North Pole, produces heavy hydrogen tritium. And also apparently from the atomic bomb testings of the 1950s, put tritium into the atmosphere. And tritium radioisotope analysis is how a lot of water scientists guess the age of water. And you'll see these papers, these news stories about this water is this old. Well, how did you ascertain that? Oh, we measured the tritium levels in the water and they were very low. So therefore this water is very, very old. Well, what if it's primary water coming up a clean channel and it's very low in tritium because you've got a primary spring source that you think is this ancient water, and maybe it is ancient because it's never touched the surface before, but you're making a series of assumptions based on an incomplete model and jumping to conclusions, and your conclusions may not be correct. We can also look at color or metric analysis, where you add reagents to water. There's a color change that happens, and the darkness or density of the color can tell you the concentration of molecules in there. You can also look at liquid chromatography with tandem mass spectrometry. This jumps off into organic chemistry and biochemistry, water analytic analysis, chemistry, molecule assertion mixtures. So we've got radioisotopes and we've got chemical analysis with various instruments. Now, a lot of clients are saying, well, do I have primary water? How do I know I have primary water? Well, how much do you want to spend on lab analysis? How much does it really matter? Smell the water, look at the water, taste the water, test the water at a lab. Is it clean and free of bacteria? Is it have an appropriate chemical profile, that it's not too high in any elements or molecules that you want to filter out, like iron or manganese or aluminum or lead or mercury? You obviously don't want that in your water. So you locate a water source and test that. Now, you could have primary water that has lead or arsenic or mercury in it because the water is made in the earth and it's coming up to the surface. And an analogy I like to use is you leave the house with clean shoes on and you go on a hike. And you come back to the house, and whatever is on your shoes is a product of where you hiked. Maybe it's some grass, maybe it's some stickers, maybe it's some mud, maybe it's some paint, and that's all a factor of where you hiked. Well, water is a solvent, and it puts other elements into solution. And steam is a really good solvent and will put things into solution. And water sitting in a trapped channel for a long period of time on its way to the surface will have time to put other things into solution. And so you can have things in your water that are a factor of the path the water took. You can find primary water everywhere. Generally, granite and volcanic geologies yield the best quality water. They put the less things in it. If you have water coming through limestone, it's going to be really high in calcium and it's going to be hard water and it's going to clog up your faucets and leave spots on your windows. And that could be primary water, but it's passing through that substrate and it's going to put that into solution and you're going to have that there. When water gets close to the surface, you have surface water that gets down below the surface, and where you're tapping your water may have a mix of surface water and primary water. That can be where it's good to look at that oxidative layer and get below the oxidative layer so that you're getting a cleaner water source. And then you're going to have a higher chance of being away from bacteria and having water that you can drink right from the wellhead. Were there some other questions in there that we missed?
Sounds good to me. You covered a lot there.
Okay.
In addition to the chemical differences between the contaminants that may possibly affect the outcome of your results, is primary water structured any differently than traditional precipitation that comes from rainwater? That's a lesser known factor of water that people don't understand. That water comes in different structures and therefore is more depending how it's structured, it's more viable for biological uses and all this kind of stuff. Is it different in that regard as well?
Well, one thing with there's many things we can speak about structured water, but one thing that's really important for our health is charge. And the positive way to be charged is negatively charged, which in a traditional explanation is an excess of electrons. And it's observed that volcanic spring water will come out negatively charged. And the earth is negatively charged. And this water coming up from within the earth tends to be negatively charged around negative 150 to 300 millivolts. Around 200 to 300 millivolts is a good negative charge that tends to cling on that water for a while. And you drink that water and that charge gets incorporated into your body. And now you have more charge and you are in charge and charged up. What that looks like, there's different ideas. Some say that it's H3O2 structured water, or that it could be similar to easy water. I'm not sure, and I think that there's still some explanations and investigations to be done there around like what is the molecular structure. But the charge of the water is easy to observe and seems to be a clear link there between that and health. I think that's a common thread there with eating living foods. This idea that you want to eat food with a lot of light in it is, I think, something addressing to having something more alive has more charge in it.
So what are some of the main sources of primary water that most people would be familiar with that they have no idea is primary water? And we've been hearing forever that they don't really know how the oceans were formed. Would it make sense logically that the water from the oceans actually is primary water as well? All water on Earth ultimately came from the process that makes primary water in the Earth's mantle, I presume.
It would seem that way. You know, the alternate hypothesis that's taught in earth sciences that, where is the origin of water? That it must have come to the earth through billions of years of aggregating from meteors and comets and asteroids, extraterrestrial water.
And that one seems a little far-fetched to me, at
You know,
least
if we
in the
have
amounts that
if
we have it.
we have a lot of water here, And if we had billions of years of scattered extraterrestrial meteorite water depositing that brought the water here, why isn't that happening now? If that was a persistent trend for billions of years of meteoric water precipitate deposits from an outside area, then why wouldn't we still be seeing that? I asked someone this the other day, and they're like, well, um, all of those meteors got used up in the solar system, and they aren't there anymore. Well, that's kind of convenient. Okay, let's run with that. So we had all this water deposited here a billion years ago, over billions of years, it rained down, and now we have the water. If that's true, we would have lost that water to space long ago. What would keep it from going out and going up high into the atmosphere and being lost? Trees and plant life transpirate and pull water out of the soil and put water in the atmosphere. And yes, clouds kind of hang around a certain elevation. But if that was a one-time input over a period of time, a long time ago, we would have lost our water by now. So when you dig into it a little bit deeper and think about it, that theory starts to fall apart. I'm not giving the best explanation there. I'd refer you back to Stephen Rees addressing that question in the 1980s in his televised interviews. Second part of the question was, sorry, Mike, what was the second part of that question?
Second part of that question. Oh, good.
Um,
Uh,
well, geysers, springs, oases, these are
oh,
sources
well,
of,
basically, I mean, you kind of answered it. It sounds like it's not really known, but some of the, what are some of the main sources of primary water that are obviously primary water that everybody knows about but doesn't know they're primary water? I would say
ah,
geysers,
yeah,
oases, like in the
sure.
desert where there's no other possible way, you know.
Yes. And even in places where you think, oh, that's just from rain and snow melt, but maybe there's a spring source underneath. And we have found springs at the bottom of the ocean. We've found hot and cold springs at the bottom of the ocean or right off the coast, off the beach, where there's fresh water coming up out. If it's right on the coast, okay, that's just some underground channel coming off of the rain and coming up. But at the bottom of the ocean, and in the alpine lakes, uh, you, you can find lakes that one might just casually dismiss as being accumulated rain, but are probably of primary origin. Crater Lake, Lake Tahoe, and all the smaller lakes running up the Sierra Nevadas and the Cascades, the Ring of Fire, all the way around. When you look through those granite and volcanic mountains, you find all of these lakes. They're being fed, they're leaking out of the sides of volcanoes. Clear Lake and volcanoes all around, you find a lot of water leaking out of the sides of volcanoes. You can find extinct volcanoes that will burp precipitation, and you'll have a cloud burp and form out of the top of a volcano in the middle of a desert. When you're out in the dry deserts, and you find these volcanic mountains, why do clouds gather around the top of the mountains in the afternoon when there's no wind and no precipitation coming in from the coast? The
Hmm.
precipitation is probably coming out of the mountain. The mountain itself is transpiring volcanic water vapor as the day heats up, and it forms a cloud above it.
Is it known
There's
exactly how primary water is created in the Earth's mantle? Is there,
there are papers that have been written and different theories, and the absolute knowledge is hard to say because it's way deep down there and it's difficult to get down there. Nobody's been down there. A good example, though, is the super deep well bore project in Russia. that was drilled between the 70s and the 90s. Took them 20 years, and they did the biggest, deepest drill ever. And the take-home lesson from that is the observations from what they found were all different from what their predictions were. They predicted the pressure and the temperature would go up at one rate, and they found that it was another. And they also found water present where they said that water couldn't exist.
Hmm.
So the deepest we ever drilled, we found water where the geologists, geophysicists previously said water couldn't exist. Now, in 2006, there was a series of papers called Earth's Deep Water Cycle, published in the Journal of Geophysics, where they published about how the Earth makes water. The term was coined mantle rain, how rain of water was made in the mantle and rained outward into the crust. And there are various theories as to how the Earth could make water. Experiments in the last 20 years of putting minerals that would be found deep down there under pressure and temperature saw that they could produce water from geologic minerals as a byproduct. Now, another theory I heard from a friend that I think holds water is that quartz piezoelectricity is driving the process. There's movement in the earth. When quartz rubs on itself, it creates piezoelectric electricity, plasma. And quartz is made out of silica dioxide. It's two oxygens and a silicate. And hydrogen is present on other molecules as well as being present freely deep in the earth. So the movement creates electricity with the quartz, liberating oxygens, which the electricity ignites the oxygen and the hydrogen, and that combusts and condenses into water. And you get a silica hydrate and water as a product of quartz electricity driven combustion of oxygen and hydrogen. And water under extreme temperature will decompose back into oxygen and hydrogen. And then the quartz electricity plasma ignites it again, and it burns and comes back together, and it breaks apart and comes back together, it breaks apart, comes back together. And it does this over and over and over and over again. And this is happening all the time in the earth under continuous since time immemorial, and creating a mass of water that's pushing up. Scientists recently discovered a sea of water off the coast of New England. Geophysicists have located a massive ocean of water under China, which is really the Mongolian mountains to the Himalaya mountains. There's another massive ocean of water, according to geophysicists, under the Rocky Mountains from Idaho to Arizona. And there are these hotspots of water producing activity that seems to correlate with the largest mountain ranges in the world. I think that we will tend to see more primary water coming out of mountains than you will in alluvial basins and mud flats and sand flats. However, you can drill deep enough and find it anywhere.
Is it at all known if this process happens on other planets and moons and other bodies, celestial bodies out there? Has been detected in any way, or probably hasn't really been explored too much because it's barely been explored here, but it would make sense if it was everywhere because of the
Yes.
chemical and
Personally,
physics involved.
me personally, I would say I don't know. However, there's a lot of papers that have been published by astronomers about there being a tremendous amount of water in the universe, and that water is a critical feature in planetary formation, and that there are clouds of ice crystals in space. So there are those who say that there's a tremendous amount of water in space, that it's a common and abundant molecule out there.
I mean, after all, if they're
I
proposing
don't know
that,
because I haven't been to space yet.
we of course, I don't think anybody really knows, but it makes you wonder. But if they're proposing that all this water came from comets, it's like, well, where the heck did that come from? It's like water just spontaneously was created on comets? That seems a little, I don't know. Not in any way I could think of, but reality is stranger than fiction, as we all know. Um, well, cool. Back to your
And these
field.
guys say there's all this water out in space. Yeah.
Back to your field. What's your success rate when you're out there doing what you do? Like you've already established that primary water is pretty much everywhere. It's just a matter of feasibility, as if you can get to it. How do you go about what you do? Like, how is there a certain methodology you employ to survey land to see if it's just suitable for drilling, or do you just like start drilling and dig in and see what comes up?
Yeah. So this outfit that I'm working with, Primary Water Technologies, has a success rate of about 90%,
It's pretty
with
good.
80% of that contacting spring water, quality water. Sometimes people might have things in their water they want to filter out, but generally it's high quality water that is clean and safe and ready to drink from the wellhead. How we do this is using an innovative combination of tools, using radiometrics, using a gamma scintillation counter to meter the radioactivity coming out of the earth. Water has many special properties, one of which it absorbs and dampens light. If you are a scuba diver and you go do deep diving, or if you've watched a video of a free diver doing the world records, it gets quite dark rather quickly as they get down there deep. That's because water dampens and absorbs light. Similarly, with gamma wave radiation, which is also EMF wave-based like light, water absorbs and dampens that. One way that this phenomenon is employed is in nuclear reactors, where they have a observation window to the reaction chamber. They'll have two windows with a aquarium of water in between. So they'll put 2 feet of water between two plate glasses. So they look through the water to observe the chamber, because they know that that water is going to dampen the radiation that's in the chamber. So water absorbs and dampens light and radiation. So when we measure the radiation, we can detect water shadows. So we surface map an area and look for the shadow of the water from the background radiation coming out of the Earth's crust, where there are radioisotopes below where the water is. That water is going to absorb and dampen that. And it's a bit like looking for faces in clouds, but we're looking for trends from high to low shifts that can indicate where a fissure could be and where a water source is coming out and flooding an area. And then we have another tool that uses a passive seismic technology, passively listening to seismic activity of the Earth, and called resonance acoustic profiling. We're making a profile using the acoustic resonance of the ground. And we listen to the surface of the ground and interpret the quiet standing wave hum of the ground and break that down with some sophisticated geophysics and statistics to identify where there's a weak spot in the ground, because this solid glass is going to vibrate similarly. But if I have a gap here or a fracture in the glass, that's going to vibrate differently than the solid glass itself. And by
Hmm.
understanding that and analyzing that, we can find where the fractures are in the ground, and we can look at different depths of focus with different frequencies and correlate that with the shadow of the water from the radiometrics to find where a flooded fracture and fissure is. It's guesswork, but it's informed guesswork, and it works pretty well.
So the 10% that you don't have any results, do you at least access groundwater, or is that completely nothing is obtainable at that point?
can be a mix. Maybe we had less water than we are looking for, or at different depths than expected, or at other times maybe there's practically none there. I've had a person where they're like, we didn't get any water. And then I talked to them a little later and they're like, oh, well, we're getting 2 to 3 gallons a minute, which is not a lot. But if you're pumping it and filling a tank and you fill your tank, that could be enough to run your house. So, that's where it's location, location, location. And the idea there being, how deep do you want to drill? And, can we keep you in the couple 100-foot depth range without having to go super deep? And that can be enough water to take care of your needs.
Price wise, is it more
And
expensive to do primary water searches than just standard well digging, or is it comparable?
It can be comparable, and generally it's more expensive. Generally, we're referring people to drill past 150 feet. Some people will have standard wells that are 70, 80 feet. For example, I was out in Northern California, and these people all had wells around 60 to 80 feet. And all their wells dried up in the dry months. Between 1 month a year, generally 2 to 3 months a year, their well ran dry. Sometimes it could be 6 months a year, maybe 1 month a year in a high rain year. But they always had a few months where they didn't have any water. So they had a bunch of water tanks that they'd fill up during the rainy months. So during the dry months, their well would be empty and they'd live off of their reserves in their tank, because the water they were getting was fed by the annual rain and would dry up in the dry season. One main benefit of a primary water well is having a regenerative water source that's regenerating from below, that's being fed from the earth, that's not rain, snowfall, precipitation dependent, that gives you water every day of the year. Nobody wants their tap to run dry. You go and turn the sink on and you get a little drop, 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 and it stops. That's a doom feeling. So that would be the main benefit. It can require going deeper. You can encounter it shallow. You see it at the surface with oases and springs. You can pick it up at 60 feet or 100 feet. Generally, we counsel people to go past 100 feet. I'd say most of our targets are in the 100 to 500 foot range. And a benefit of going a little deeper is you get away from the surface water. So the water you're pulling up through your well is free of surface contaminants, where a shallow 100-foot or less well could have fertilizers, nitrates, coliforms, animal poop, and other surface contaminants in the water. When you get into a fracture away from the surface, then you're getting further away from surface contamination and generally getting a clean source that you can drink untreated.
Is it pretty much a given if you have property that has like a spring on it or some source of water that flows from the ground year round, that's most likely primary water in origin?
It's a possibility, but not a certainty, because
Hmm.
that spring could be the classical geology book definition of a spring, of precipitation being caught and being the straw model of following gravity and coming up out of a spot. A lot of springs can be that gravity flow, rain precipitation percolating through, which can push up because of aquatards. That model can be correct. I just don't think that it's correct all the time. And I think that a lot of springs are primary sources and not atmospheric percolated precipitation sources. But it's also geology dependent. If you're in a place with a lot of limestone caves and caverns, and there's some hills over here that get a lot of rain, they're gonna flow through those channels, and you'll get springs that pop out of the side of the mountains. I think we see that more in limestone rich areas, maybe Ozarks and Appalachia. So there's no clear answer there with geology because it's heterogeneous and there's all sorts of different situations out there. Yes, it can be, not necessarily.
So I would imagine that even primary water, if it's percolating up to the surface, can find ways to be contaminated like any. But I would also guarantee that pretty much all atmospheric precipitation at this stage in history is totally toxic. And would it, even if you do have a primary water source on your property that percolates to the surface, would it be better to dig as deep as possible to get the purest, unpolluted source of water as possible, or is simply purifying it with a some kind of filtration system uh, beneficial with primary water in some way more so than atmospheric water? That meaning, are there like less contaminants in the primary water if it is indeed contaminated?
Yeah. Well, look before you leap, observe and ascertain what your unique situation is before you figure out what to do and make a custom strategy based on that. So let's say you've got a spring in your backyard and you're wondering how clean is it? Well, take a water sample and send it to a water lab and get it tested. And if you are curious if there's surface mixing, you could look for oxidized compounds. You could do the more expensive laboratory analysis. You could also look for microplastics or other atmospheric contaminants. And do you see those in there? If yes, then maybe you want to consider drilling deeper. If no, and you've got something good now, well, then don't fix what ain't broke. But if you do want it to get better, then and you are drilling a well, then as you go down, you can take water samples and look to get past that oxidative layer is a clear indication of where you're getting away from surface mixing. Now, you could see that in a thermal hot spring or in a cold spring. And to what level of is some surface mixing acceptable is up to you, but I'd want to as pure of primary source as I could so that it's free of atmospheric and surface contaminants. For those of us paying attention, there's a lot of contaminants that are now ubiquitously present in rainwater and in our bloodstreams and in mother's milk and semen even, and in our brains. So one good thing we can do is drink water that doesn't have those contaminants in it to help us flush those things out, along with all sorts of other things we can do to flush ourselves out. A clean water supply is a great first step.
Are some of those newer purifiers that are out in the market now that are designed to structure water and all this kind of stuff, is it trying to emulate what primary water is? Do you know, or does primary water offer the
I'm
most
sorry you
optimal?
I'm sorry you broke up there a little bit.
So, all those some of those newer water purifiers that do restructuring and all this fancy stuff. Is primary water like the most optimal type of water structuring and chemical composition and blah 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 that is the most optimal for biological systems like the human cell? Or is it just doesn't matter?
I think well, I think it depends on who you ask. And to answer that in a couple ways, it's hard to get better than natural nature. That said, Mother Nature tends to do it best. And in our innovative tinkering in agriculture and technology and stuff, we could think that we come up with it better, but perhaps Mother Nature was doing it better all along. That said, we are innovative creators, and perhaps some of the things that we are doing can have an extra positive effect. Are man-made water structuring devices better than naturally structured water out of the ground? Maybe not. I would rather drink negatively charged natural volcanic spring water coming out of the ground, whether it's hot or cold, and I have to let it cool off, provided it's not too minerally that it's not going to give me kidney stones from getting too many minerals, but in the appropriate ppm range. And variety is the spice of life. I like to drink multiple water sources, but when we're helping people find water, I say, ask people to ask themselves, is this an acceptable daily driver of, common supply? That said, the things we can do with water in cleaning it up and energizing it and structuring it are also phenomenal. And that science has been incredible in the last 100+ years and accelerating even more so. So if you're on municipal water and you have to drink tap water because that's your situation you're stuck at, then I tell people get that water naked, strip it down to nothing, as in, filter it really well. But then you've got clean water, but you still have dead water. So you want to vortex it, energize it, structure it, charge it, and this can be done through various ways. And that's the next step. People understand water filtering, getting out fecal coliform bacteria and waterborne illness carriers so they don't get amoebic dysentery or something. We understand how to pull iron and lead out of water with filtering. We can RO our water. There's all sorts of ways we can clean up our water and get contaminants out. And then it is good to structure it, vortex it, energize it in various ways. Is that necessary with primary water? I don't know. I've got several water energizing and structuring devices, which I'll sometimes do to primary sources and spring sources, but I generally collect spring water and drink that because I'm on the road and I don't have a primary water well with me when I'm going along, and I'm going to places that don't have water. So I'll collect good water where I can, and I generally drink that straight from the spring source.
This is a little off topic. What do you think of
Um,
those
the
emergency
easiest,
straws?
the, I've asked about those, and I hear that they're okay. They don't have a long life. They don't last very long. So you could have that in your kit, um, but I don't know how long it's going to last. It might be better off to invest in a still so that you can distill your own water.
Hmm.
If you are traveling or living in a city and the water goes bad, if you have a simple still where you boil water, you catch the vapor, you run it through a condensation tube, and you collect the water condensation, that's distilling. That's how they make moonshine. It's how they make hydrosols and do extracts of plant material and other materials. But you can also just boil water and distill it and catch the distillate of pure water. And one way to clean the three most common types of contaminants out of water. It's high energy. It takes a lot of energy to boil water because of the high specific heat of water. But in a pinch, if you can build a fire, that's a way that you can emergency clean water. Now, it's not very portable, but you can still have a still that's like the size of a pressure cooker that you could have in your house or take camping. Um, I've used those backpack filters where you put a straw in the stream and you pump it goes right into your Nalgene bottle, which is a bulkier version of those life straws. And those are great. Or you can use iodine tablets. You can use sodium chloride, chlorine dioxide to purify water. There's a lot of ways to clean water.
Hmm.
The nice thing about a trusted spring source or getting your primary water well is you've got, a source that you can drink safely and cleanly straight from that. But yeah, life straws, I've asked several people about it and I've got it's okay, it'll do the job, but it's not going to last you for a long time. I
So
don't
it's
know
suitable for an
exactly what that means, probably
emergency
less than a couple
situation.
months.
If you get if an earthquake traps you in your apartment or something, you can drink the toilet water,
Yeah,
something like that. So given
I guess so, but get some glass jugs and store some water.
sounds easier. So given the
Yep.
history and the evidence behind the existence of primary water, including companies like yours actually drilling and having major success rates, why in the world do very few people know about this?
Mike, I learned about this 2 years ago. I didn't know about it. Uh, um, I didn't learn about it in school. Nobody taught me. I didn't see it on TV. There was no cartoon about it. That's the short answer. Why didn't you know about it before you knew about it? You
I know.
know,
Well,
it's not in the curriculum.
what do you speculate is the reason? I mean, I'm sure we all know the actual reason. It's all special interests and politics, but you know how the word gets around these days. Somebody
Well,
things go
yeah.
viral, but this one doesn't seem to go viral. And this is like one of the biggest things ever, right?
People have been talking about it for centuries. And though you and I didn't know about it until the recent past, people in Europe were talking about this for 500 years, more actually. There were Ptolemy mentioned in one of his books about Earth generated water that Stephen Rees brought up.
Wow, it goes
So,
back that far, huh?
yeah, it goes
Wow.
back that far. It seems that there was an indigenous understanding and knowledge about this water coming out of the earth being of deep earth origin and perhaps inner earth synthesis origin. Um, but a lot of indigenous knowledge is not taught in modern schools and textbooks, and for some reason isn't promoted. It isn't given a microphone. You'd think that something like this would be great, but special interests are one thing, to take it with a grain of salt, though. Like, I think it's fair to be skeptical. I think that ethical skepticism is the core of good intellectualism and science. And, we should be skeptical of all things. So if someone hears this idea and wants to be skeptical about it, if they're doing that in an ethical way, then that's great. Question it. Um, but yeah, there's an indigenous understanding of this. It's been talked about in Europe for 500 years. In the 1880s, Nordenskjöld got his Nobel Prize nomination for his paper about drilling for primary water in granite rocks. And Dr. Stephen Rees dedicated his life to this. He testified before the US Congress in 1960 saying, hey, this could be the answer to our water solutions. You can go find that in the congressional records. It's still there. And at the same time, his buddy, Dr. Michael Salzman, published the book, New Water for a Thirsty World, which was suppressed because of the dams and levees and aqueducts, steel and concrete special interest. And then Paul Power dedicated his life to it. And and then Mark Burr found that and picked that up. And it's a great honor to help carry this baton forward. These guys dedicated their lives to bringing an awareness that would end water scarcity on Earth, that can, that will. And I think that's a noble cause to pursue. It'd be, I think, a great step forward in moving away from scarcity consciousness in general and into a receiving of abundance mindset that there's an inexhaustible supply of water beneath our feet that's accessible, clean, ready to go. There's oceans under the oceans, oceans under the continents, like great lakes upon great lakes upon great lakes beneath the mountains of fresh water leaking out. That's just a dribble of evidence of the water contained down there. Why? Why indeed, Mike? You know, supply and demand, Econ 101, scarcity maintains the price of a thing. You know, why don't we have wireless energy transmission that can't be easily metered? Because it can't be easily metered. But, you know,
Hmm.
that seemed unacceptable
Can't be
because they
centralized.
wanted to meter it. Um, yeah, and like there's states now who are saying that there's a water scarcity issue, who are putting water meters on people's wells and want someone to come out and read the meter of how much water came out of their well and want the person to pay money to the state for the water coming out of their well on their land. That's a
Yeah, that
thing
was my
in
next question is what are some of the
California.
political hurdles that you've encountered? It's like I'm from the state of Nebraska and my family still lives there and my parents live in the country and rural Nebraska is known for its one of the largest aquifers left in the United 48 states. And there's a moratorium on building new wells. They literally just like said you can't build drill for any more water. Do you encounter that when you're out on the field? Like you think you can do a job and then you find there's like some ordinance or some, BS
Yeah,
ordinance of
water
some
law,
kind that prevents you?
water law is one of water law is one of the most complicated laws of private property rights out there because it's such a fundamental resource that historically, when people have gotten to a new area and said, dibs, this land is mine, they're also going to say, dibs, all this water flowing through the river is mine. And years go by, more development happens, more people want access to this water source, and people fight over a thing. And you've got who had the original dibs, who had the later dibs, how the government is negotiating that between the farmers and the municipalities and cities and the original ranchers and who were grandfathered in. But everybody needs enough water and it's a public trust, but this person had first dibs and the whole thing becomes a complicated mess. Water law is one of the most complicated laws. Um, and there are special management areas that have popped up around municipalities that restrict the ability to drill a well or what you can do. Los Angeles County has a well drilling moratorium. You can't drill a well in Los Angeles County, but Ventura County next door is a right to farm county, and you can totally drill a well there because they are right to farm. Um, it's political strategy. It's how much a place has been built up. It's mindset or rather understanding. Because I wanted to touch on this earlier, a point that Stephen Reese makes. There's two kinds of groundwater, two main kinds. You got primary water being made and coming up, but you also have basin water because water will rain down and it'll run down the hills and it'll go through the sandy gravel alluvial basins and hit a hard pan and fill up that pan. You have an underground puddle, pond, lake, reservoir, and that groundwater has an even level, and that could be a valley floor of an alluvial basin of alluvial sands and gravel. And a bunch of farmers go in there because it's easy to farm there in the alluvial basin, and they start depleting this water. And the water goes down and down and down. Oh my God, we're running out of water. We got to stop drilling wells. But they're not over drilling into the granite and the volcanic and the faults where the rivers of water flowing up from the deeps are. So that is a matter of we have a lot of education to do. There's a tremendous body of evidence of thousands of wells at this point, and some really good examples of drilling into a fault, producing tens upon tens upon tens of thousands of gallons a minute, that implore us to see, hey, this was a smashing success over here. Maybe we should see how much this fault of river water fault can produce, and maybe we should go try it over there and over there and over there. I saw that we have a lot of faults through here, and maybe we should look at more geologic contact zones and faults for major water sources. So that's the mission now, is building an awareness to roll the dice on doing some more surveying and poking some more exploratory holes into some potentially major water sources, monitor all the wells in the surrounding area. Did any of their production decrease? Did any of their levels decrease? Or is this vein of water independent of what other people are drinking from? We should do those experiments. It's worthwhile. It's, a matter of scarcity versus abundance.
So when I've heard Deborah Tavares talk about this subject, she claimed that those places that have been accessing primary water throughout its history have often have higher IQs of its inhabitants. And she also talks about the fact that Libya under Gaddafi was actually trying to access primary water to create an oasis in the desert. And that was the primary reason that they were taken out, because they were getting a little too cocky with going rogue and decoupling their currency from the US petrodollar. And as we all know, with our well-oiled war machine, we're not going to have any of that. So, do you think what she was talking about is hyperbole, or do you really think that she was onto something when she was pointing all that out? I mean, or is it just speculative on her part?
Did Deborah make the claim that drinking primary water resulted in a higher IQ, or did she make the observation that people drinking tap water had a lower IQ than people drinking well water?
She made the
Because
claim, she made the claim that places like Hungary have traditionally, because have you ever been to Hungary? I've been there a few times.
no, not yet.
And there's a lot of geysers there and a lot of
Mm.
hot springs, and it makes sense that that would be an easy place to access primary water. And if you know anything about Hungary, they produce an above average amount of geniuses, and the language is like one of the most ridiculously complicated languages in the world. It totally just kind of evolved in the middle of Europe, sort of unrelated to everything. Anyway, it makes
Well,
sense.
yeah, it makes sense. What I was saying before, that I think nutrition is fundamentally about charge. You want to be charged up so you can be in charge. And whether you get charged by going barefoot on the ground and earthing to absorb the negative charge from the earth, whether you are sun gazing and absorbing energy from the sun, whether you're absorbing the chi and prana from the area around you, whether you're drinking cold pressed organic fresh squeezed juices that are freshly harvested. I think that drinking primary water, which tends to have a negative charge, it's got more charge potential in it. It's containing more electromagnetic energy in it. That I think that's the foundation of nutrition. So if you're drinking negatively charged primary water and otherwise have a toxic free or low toxin environment, then you're going to be a more high functioning human. I think that eating clean food, breathing clean air, drinking clean water is step one to being healthy and high functioning. And that we have an incredible potential if only we're not calloused by toxins.
That leads me to a
Not
question.
revolutionary there. We know fluoride depresses IQ in kids, and I think that lots of other toxins would too. And so if you're toxin free, pollutant free, and high charge, then yeah.
That leads me to another
Well, I'm sorry, what were you gonna say?
that leads me to another question I just thought of. It's like, do you know of any uh, orchards or food growers that have accessed primary water that are using it on their crops? Because even if we try to avoid fluoride and all these things in our water that we actually drink, we're still getting it in the food supply to a certain extent, even if it's probably
I yeah, I think a
diluted a
lot
bit.
of I think a lot of farmers are using water that is a primary water supply, just as there are farmers that are using, sorry, precipitation water or ditch water. If you're out in Colorado and there's all this snow melt running down and there's these snow melt ditches and you have rights to the ditch and you flood your crops with the ditch water, surface water is the most easily accessible. So if you have surface water, you are going to tend to use that. If you have shallow water that may not be primary origin, maybe it's archaic, ancient rainwater reservoir or a seasonal well, but it's accessible and that's good enough to grow your hay, alfalfa, apples, pears, peaches, whatever, then farmers don't tend to have a lot of money and they're going to do what's economical and makes sense. However, if you want to farm in the desert, you're probably better off finding a primary water supply. And where you look on the satellite and see these pivot farms growing hay and alfalfa out in the middle of Nevada and Utah and Arizona, they're often probably most likely uh, running off a primary water supply. If they don't have water rights and they're not tapped into a main vein like the Colorado River, um, a lot of those farms are running from basins of snow melt where things collect and reservoirs and waterways. But a lot of people also find where the water is leaking out of the earth, a hot spring area, and down a little bit, they're punching wells and finding water and running their farms that way.
It
What
would be,
is the vitality of that fruit versus atmospheric water? That'd be a fun experiment to do. There's a lot of fun experiments
it would
people
also
do.
be cool if they eventually develop some kind of certification for primary water grown vegetables and fruits and food supply and all that kind of stuff. Grass-fed beef raised on primary water, the whole works. It sounds like a something that world that should be, but for some reason we're just not quite there yet.
Well, there's a lot we can do there, and let's say you're buying a hamburger and it's organic, but that is just one certification. We could create new certifications to qualify the quality or the process that a food stuff went through. But it's probably best to, develop a personal relationship with your local farmers and become friends with the people at the farmers market and know your farmer and know their process. And so that you know your food and you can, have a better understanding of the integrity and process going into those things and, exercise discernment and being a qualitarian and taking an active pursuit of sourcing out uh, good nourishment. It's a good thing to do. Um, that is something that could happen. I think, yeah, it's something that could happen. Over in the brewing industry, I think the next evolution in the beer brewing industry is like people in the microbrew industry. They're all like, there's all these microbrews out there, and they're trying to differentiate themselves from each other. They should brag about their water supply. Are you just using tap water to make your beer? Are you having like a really cool filtering and structuring process that happens to your water before you make this water-based product? or other drinks at the store. Kombucha juice that's 15% juice and 85% water. Like all of those water-based products should brag about their water source. I had a friend who makes kombucha and jun, and she would drive up into the Colorado mountains and collect like 45-gallon jugs of spring water. She'd go collect spring water, she'd bring it back down to her kombuchery to brew her kombucha with that. But big kombucha companies that you see at the supermarket, GT, Synergy, what's their water source? Why don't they talk about their water source on the bottle? And should their operation, or beer, kombucha, whatever.
You have totally frozen up. Looks like Tyler is suspended in time there. All right, are we back on?
Oh, yeah, I was just calling you to say what's going on. All right, we're back on.
You froze up and then the whole screen disappeared. That's what happened. Um, that
Short intermission.
what you just said
Okay,
reminded me of back in the 30s, they were adding vitamin D to beer to give it boost its health claims, and I think the feds cracked down on them for that. Um, but
which
anyway,
is kind of similar to like fortified flour. Oh, we're putting D3 in the flour.
I know it's like we now add iodine to Lucky Charms or something, or organic Pop Tarts. The whole thing is kind of ludicrous. Um, Getting back to Libya, what do you think about that
Yeah.
situation? Is there any
Okay,
truth
so
to
yeah,
that?
for listeners who are unfamiliar with this backstory, Gaddafi was working on a project called the Great Man-Made River Project. And they located and drilled a whole network of wells south into the Sahara Desert and into the hills, moving away from the Mediterranean. And it's really easy with 2 minutes on a Google search to find a map of the Great Man-Made Water Project network. It's pretty extensive. It was a great buried canal, buried pipe that was 12 or 15 or 20 feet wide, stretching hundreds of miles. And when you look at it, there's a bunch of branches that go out into the desert to the south, funneling water up to the coast, and they were going to take care of all the water needs of the country. And I guess that project got interrupted when Benghazi got bombed and other things happened, and he lost his life. Now, is that the reason he was taken out? Is it the primary reason? Is it one of several reasons? Totally possible. Like the guy was doing other things that were disruptive to a status quo, like pushing a gold-backed currency union in Africa and other such things that could threaten other people's economic interests. And comes back to the good old theme of economic special interest doing things that might not be for the benefit of the greater amount of people. I don't know. I wasn't there. I'm not in the State Department or the UN or whoever was involved in that. Um, but it's possible. But I'm still going to keep helping people find wells, and I'd like us to. I think that idea is a good thing to do. I think we have tremendous resources of water around the world, and similar projects would be the nation state regional solution, as opposed to just a well for a farm, a homestead, someone's home. That if we want larger waters as a alternative to dams and reservoirs, let's go drill the faults that are flooded, and then run those waterways where they need to go. They could stretch very far. They could be a really big project like Libya's thing, or they could be locally situated and not have to go that far and plug into an existing infrastructure or lay new infrastructure. Let's
Oh,
have microplastic forever chemical free water. Yeah.
and that was my next question is, do you know of any local municipalities, whether they're cities, counties, states, nations, any larger bodies of governing factions that actually have started using primary water? I've always heard rumors that Santa Rosa, the city of Santa Rosa here in California, was looking into it in the 60s, and for whatever reason, they just decided not to and moved on. Uh, is there any
All
place that
right.
is there any place that has successfully developed primary water as a source of water for their communities?
I would say invariably yes. I don't have examples to list for you of this town, this municipality is definitely on a primary supply, but there are a lot of municipalities that run off of wells and that run off of deep wells, and surely some of them are. Oh yeah, I'm sorry, I'm just having a brain fart. A great example, California City out in the Mojave Desert, out by China Lake Military Base on the east side of the Tehachapi Mountains in Southern California, deep in the desert there. There's a town called California City, California, established after wells were located in flooded fissures running under the desert and drilled. And when the developers wanted to do this, the county was like, "You're crazy. You're wasting your time." And they're like, "Well, I want to go do it." And they're like, "Sure, go waste your money." And they hit this water, and there's a city out there in the middle of the Mojave supported from wells. They're far, far away from precipitation. Some say that this water is running from the Sierra Nevadas and going under the desert and over to them, but it's probably a primary source. And they have a lake and a pond and a golf course and 3 wells that have been producing a tremendous amount of water for 50, 60, 80 years. And
Looking at the map
perpetual
on
water. So
Google Earth right
yeah,
now, and yes, there's quite a large.
we got a great big green spot there, and that big water spot there in the middle of the brown
It
desert.
looks like a little oasis in the desert there. Wow,
Yeah, that's
interesting.
possible across the deserts. That's possible in the municipalities in New York, Manhattan or Queens or something. They were digging a foundation for a building and opened up a vein of water, and it was gushing out, and they destroyed it. Like there's an industry about dewatering the ground when water's in an inconvenient place, and instead of piping and capturing the water and supplying a water supply, they go in and blow it up and pour concrete on it and plug it up so that they can build the building that were planning on building there before they unearthed the water. That happened, I don't know, like in the last 150 years. It's a good example. I just saw an example on video of the same thing happening in Sunnyvale, California, Silicon Valley, in the thirsty San Francisco Bay Area, where they're worried about water scarcity, or that's how they're talking about. And similar thing, they're digging a foundation to put a building in down in Silicon Valley, and they hit this vein of water, free flowing, 150 gallons a minute, clean, beautiful water at sea level, right next to the brackish San Francisco Bay. And did they develop this into a well and supply the water to the local area? No, they also de-watered it and blew it up and concreted it and capped it so they could build a building that they were planning on building in that footprint. We stumble upon this water all the time, and oftentimes we destroy it because so and so had the plan to, put up a building there, and this spring source they found was inconvenient for that.
Wow, probably happens more
Um,
than we'll ever know. And
yeah.
I bet you're right. I bet a lot of municipalities have tapped into this and they're just not broadcasting that they've done so, so they don't get any.
Once people have their water supply, they tend to be pretty quiet about it. Like,
Yeah,
I got my money, I got my water, I got my resources. I'm not gonna like broadcast, oh my gosh, we've got this thing, because then maybe the neighbors are gonna want some of it. And people are funny about their resources, especially with something so important to life as water.
I guess the what we've been brainwashed to believe is that water is scarce, when in reality it's not.
And that's the best news. Yeah, and that's the
It's one of the
best.
most
Yeah,
abundant things on
when
this
in
planet.
reality,
We are the water planet, for God's sake. Um, are there any classes or for those? I mean, how do people learn about this? I mean, does your company just do the drilling, or do you offer educational services on, to
I
broadcast this
talk to
to?
people practically all day, every day. Yeah, yeah. People can email me. We can put some information in the video links. I'll send you some links to post at the bottom there.
Please do.
Um, yeah, there's a website called the Primary Water Institute that
Very good
was
site.
Dr. Very good site. I learned a lot reading that site and that magazine, and there's been some great effort put into that by water enthusiasts, primary water enthusiasts over the years. Started as Stephen Reese's educational institute that Paul Power took over, and then upon his passing became the Primary Water Institute. Great resource. Also, we have a resources page on primary water technologies um, that has a great deal of information there. There's like 150 slide PowerPoint slide presentation that you can just read through that give you a great deal of information. And if those don't do it for you, then fire me off an email.
So,
There is a call put, there's more we could do with both those websites. There's more we could do with the Primary Water Institute. I think that we could build a primary water library, though online is kind of the best way in the modern time to get the information out there. There's more to do.
so we all know that governments like to centralize everything and control it with iron fist. How do we ensure that once this vast source of fresh water is discovered by the masses, that it doesn't become the property of the billionaires and those who want to control everything? How can we really make it liberating uh, democratic process that everybody can access? Because
If you
who was
own a
it
piece
that
of land, you can probably find it under the dirt that you're on.
that
That's
gets
that's the nice thing about primary water is while there are big veins of it in some places, there's also fractures and fissures and smaller waterways practically everywhere. So it's already a fractalized, decentralized discharge system, like how a tree branches out and there's so many leaves on one tree. The trunk is centralized, the leaves are decentralized. And there are primary water sources fractionally decentralized like that through the crust already. So if you can punch into the ground and you can figure out where to punch to access a sizable vein at a shallow depth, so you don't have to drill so far and spend so much money doing that, then you can get out. Now, the other part of the question that you're inferring there, like if the state said, well, that's mine, and we have to fight robots for clean drinking water in the future, well, it might go that way. I
it's
hope
not
not.
unthinkable. The AI wars over
Yeah.
water or something ridiculous.
Um,
It's just that they
yeah.
always just like to throw
I
obstacles.
try to keep my head in my.
Yeah.
Oh,
Uh,
you're freezing up again.
yeah, it is. The internet has gotten a little patchy on one of our ends. Well, we've already been going like an hour and 45 minutes, it looks like. Or is it, what time did we start? We
Isn't
started
that funny? Like, it's easy to get into this saying, okay, we're going to talk for 20, 30.
at
I could talk about water all day. I mean, like it's such a deep topic. There's so much to speak of. But I think we got some great points. Thanks for your question and the
Yes.
opportunity to come and share about water.
Thank you for carving some time out of your busy schedule. You're a great high viber indeed. Um, do you stay pretty busy doing what you're doing? Not sure if you're catching
Do
this.
I repeat that again?
Do you stay pretty busy doing what you do? Is there demand?
There is demand. The world is a thirsty place, and lots of people are looking for water, whether they've got a property where the water is underperforming or they have a shallow seasonal well and they'd like to get a sustainable year-round source, or someone's homesteading and they bought some undeveloped rural land, and that's one of the first things they have to think about. On that note, if you're listening and you're going to go homestead, find your water source before doing other development. When we're doing this kind of water search, and it's really best to encounter raw, undeveloped land free of debris, free of mats and containers and vehicles and tractors and driveways and fill brought in from other sites. If you've got virgin land, locate your water source first. Get some stakes in the ground of where a good water vein is and know how deep it is, and then plan your development of your property around that. You can't just drill a well anywhere and get a good water supply. You need to get over those water-bearing fractures and pinpoint, locate, tap that. And you could find multiple ones, but you're not going to want to put your driveway over your well. And if you put your driveway in and your shipping containers and your storage, or put your house in first, or you put your septic in first, and you've got all this setback away from your septic, now you've eliminated all this land where you could look for water. So
Hmm,
water first, it's an important thing. Everything else can come after that.
good point. So I guess we should
We
just
can
wrap
still
it up.
you can
Wrap
still
it up
find it
there.
later, but it's a lot. It's
So I guess we should
okay.
wrap it up here. We've
Yeah.
been at this a
Let's
while.
see
I don't
how
want to
people
overwhelm
respond to
everybody.
this.
Say again? We have a lag in time now.
That sounds good, and we'll see. All
Well, be,
right. Well, I guess the ethers are telling us that it's time to go.
I guess so. Well, thank you so much, Tyler, for joining me today. And thank you all for tuning into High Vibe
Thank you, Mike.
TV. And have a pleasant today and an even better tomorrow. All right. Bye.
Bye-bye.